Session 07 Testing Celery Tasks. Testing background tasks is fundamentally different from testing regular functions because a task travels through a broker, is executed by a separate worker process, and its result is retrieved from a backend. We will cover 3 testing strategies that range from the fastest and least realistic to the slowest and most realistic. 3 testing strategies form a pyramid from fast unit tests to full integration tests. Strategy 1: Call the task function directly in process for pure business logic. Strategy 2: Use Celery eager mode to exercise the dispatch code path without a real broker. Strategy 3: Run a real Celery worker against a real broker with PyTest Celery for full integration coverage. Choose the right strategy based on what you need to prove. The simplest and fastest approach is to call the task function directly using .run. This executes synchronously in the same process with no broker, no worker, and no network call. It works for any task whose logic does not depend on Celery-specific behavior such as retries, chaining, or accessing self.request. Eager mode makes .delay and .apply async execute the task synchronously in the calling process instead of sending it to a broker. Set task always eager to true globally in a conf-test fixture. This is useful for testing the dispatch code path, such as a fast API endpoint that calls .delay, without standing up Redis or RabbitMQ. Remember to restore the setting after the test. Eager mode is fast, but it comes with important limitations. It never exercises serialization, routing, retries with delay, or worker crash behavior. It proves only that the task is callable, not that it survives production conditions. Do not rely on eager mode alone for tasks that use auto-retry for, chords, or custom-based task classes from Session 03. For genuine integration coverage of retries, time limits, and chord callbacks, run a real worker against a real broker. Install PyTest Celery and use the Celery session worker fixture. It spins up an in-memory broker and backend with a real worker thread, so .delay goes through the actual dispatch and execution path. Call result.get with a timeout to retrieve the final value. When testing a view or service function that calls a task, do not let the real task run at all. Instead, patch .delay and assert that it was called correctly with the right arguments. Stub the return value with a fake task ID. This keeps the test fast and decoupled from Celery configuration, appropriate when the task body already has its own unit tests. Testing retry logic requires the real Celery task machinery because retries use self.retry. The practical middle ground is eager mode with task eager propagates set to false, combined with catching the retry exception. Use a mock to force an external service failure, then assert that the task raises retry instead of crashing. How to choose the right testing strategy. For pure business logic inside a task, call the function directly. For verifying that an endpoint enqueues the right task with the right arguments, mock.delay. For retry behavior, chords, or time limits, use a real worker with PyTest Celery. For serialization or broker connectivity itself, run a real worker against an actual broker. Session 07 Recap. We covered 3 testing strategies: unit testing the task body directly with .run, eager mode for integration-style dispatch testing, and real worker plus broker with PyTest Celery for full coverage. We also learned mocking .delay for caller-side tests and testing retry logic by catching the retry exception. Always match the strategy to what you need to prove. Session 08 will cover Celery security best practices.